So what you're doing in this problem is you are taking the region that is bounded by the line y equals 0, x equals 0, and y equals 4 minus x squared. 4 minus x squared, you guys realize, would just be an upside down parabola. The vertex is up here at 4. Okay. We're going to take this region and we're going to revolve it 360 degrees around the x-axis. Okay. So, in a sense, you will create, I can't really draw this three-dimensionally, okay, but you will have created
wafer thingies.
Yes, yep. Basically, it gets.
I guess vanilla wafer.
Imagine this flat surface then just being rotated out from the board, back in and on the back side of the board, so it's a three-dimensional figure, okay? And we're going to find the volume of that, okay? Now, if you think of this, this is really just, if you could slice it into really, really small rectangles, if you will, and rotate that rectangle, you'd get a whole bunch of cylinders, okay? A whole bunch of cylinders. And how do you find the volume of any cylinder? Area of base times height, okay? So cylinder volume equals area of base, so pi r squared, times the height, right? Okay? Well, really here, you're going to be adding up the volumes of all of these really narrow cylinders that are formed when you're rotating this around the x-axis.
Which sounds like our antiderivatives.
Okay? Yes, which is exactly your antiderivatives. Okay, so the difference though here is the radius of the cylinder is
Variable.
the value of the function, or in other words, just 4 minus x squared. And the height of that cylinder is simply dx in a sense, or the change in x, if you will. Okay? So I know we probably wrote out the rule last time.
Yeah, we did.
So volume equals pi, because here's your pi, and then the integral from a to b of r of x squared, that's your radius squared, and then your delta x, or in other words, your dx in a sense.
And this is the other thing with all the tests.
What's that?
That's the other thing with all the tests.
Yeah, yep. And this was assigned right before spring break. It's been a while,
Yeah.
so I wanted to go back.
Do we have to know the other one too?
What
Because
goes
like
on the
if it's not
y-axis?
on the.
The washer
Wash.
method?
Yeah.
Yes. Yep, and we'll do one of those two. Okay? But so here's kind of the idea of how we're going to find the volume of this. Okay? We're really, I guess I want to make sure, do you guys feel like you understand where this is coming from?
Yeah.
Pi r squared h. And all you have are a whole bunch of really skinny cylinders that are being formed. And obviously the limit of those cylinders as your delta x approaches 0 would approximate the exact volume of that figure. Okay? So if you were going to do this one, the volume would equal the integral, I'm assuming we're counting by ones here, from 0 to 2, from 0 to 2, of the function squared, because the value at any given x value from here to here, that would represent your radius. So how long is that? Well, it depends what x is. If x is 1, plug in a 1 here, then your radius is 3, right? Okay, so that's why it's just that value. So 4 minus x squared squared dx. This is what you need to evaluate to find the volume of that three-dimensional solid rotated about the x-axis.
And then just use substitution.
No, you won't even have to. Nope. You shouldn't. I just square it and then antiderivative each term.
Okay.
So I times the antiderivative from 0 to 2, that'd be 16 minus 4x squared minus 4x squared, so minus 8x squared plus x to the 4th dx, right? So that would equal 16x 8/3 x to the 3rd (1/5 x to the 5th). As x goes from 2 to 0.
Figure the pi
It would be
out.
0 to 2.
And then all of this is multiplied by pi. Thank you.
Yep.
Okay?
Cool.
Just for time purposes here. 2 cubed is 8, 8 times 8/3, 64/3, that's 32 minus 64/3.
It's 256.
What's that?
It's 256 over P5.
Thank you.
Wow.
I was just trying to
So 256 pi over 50. Okay? If you're struggling to get that, we just gotta watch your sign and everything else. When you
Squared.
What's that?
Unit squared.
Volume.
Well,
Cube.
units cubed. I mean, I said that, but Zach was like,
Units cubed.
you're stupid.
Okay? So there's an example of the disk method around the x-axis. Okay?
Will we have one where you don't have a picture?